Good day, viewers all over the world. You are welcome to Toydel Online Class. Today, we want to look at example on the inverse of 3 by 3 matrix. So the matrix we have on the board is 3 by 3. So how do we find the inverse of this matrix? The inverse of a matrix by formula is giving us the adjoint of that matrix, in this case A, all over the determinant of a matrix. And once the determinant of that matrix is 0, it is not possible to find the inverse. The matrix is not invertible. But when the determinant is non-zero, that is when we'll be able to find the inverse, as we have explained in our previous classes. So we can only find the inverse of a non-singular matrix. That is, non-singular matrix, the matrix that has its determinant will be non-zero. So the first thing that is required here is to first find the determinants. So we'll go ahead and find the determinant of this matrix before we can do any other thing. Then, if we want to find the determinant of this matrix, we can use the normal method, plus, minus, plus, or we use Saru's rule. You can check my videos, my previous video on how to find the determinant of a matrix. So if I use this method, I'll pick the first one here. This is 2. Then I will write out the leftover. If I pick this 2 is first column and first row, I will write out the leftover, 7, 6, 4, 0. I'll go to the second one. This is minus. I will introduce this sign before I find the determinant along the first row, plus, minus, plus. So this will now be minus 3 into bracket. If I pick first row and first column, the leftover will be 8, 6, 1, 0. So I'm going to have 8, 6, 1, 0. Then I go to the last column, plus 5. I will write out the leftover. The leftover will be first row, third column, 8, 7, 1, 4. 8, 7, 1, 4. So from here now, I can go ahead and find the determinant. I have 2 into bracket. 7 times 0, that's 0, minus 4 times 6, 24. Then minus 3 into bracket. 8 times 0, 0. 1 times 6, minus 6. Then plus 5 into bracket. 8 times 4, 32. Minus 1 times 7, that's 7. Then here I'm going to have 2 into bracket minus 24. Then I have minus 3 into bracket minus 6. Then I have plus 5 into bracket 32 minus 7, that's 25. So here I'm going to have minus 48. Minus times minus is plus, that's plus 18. Then plus 125. Then finally, determinant of A will be given as 18 minus 48, that's minus 30, will be given as 95. So determinant of A is 95. So this determinant is not zero, it's non-zero. So since I know the determinant of A, then I can go ahead and find the inverse. So I know the determinant already. So the determinant of A, in this case, let me just write it somewhere. The determinant of A is given as 95. I've gotten the value of determinant. So I will now go ahead and find the inverse. So how do I find the inverse? There are 3 things involved to find the inverse. We first find the minus of A. So how do we find the minus of A? If I want to find the minus of A, minus, we find the determinant, so I will clean this. So how do I find the minus of A? I'm going to find the minus of each of this entry, each of this. So if I want to find the minus of the first one here, which is first row, first column, I will consider this leftover that I have here is 2 by 2. In each of this, if I want to find the minus of this, once I pick any of the entries, the leftover will be 2 by 2. In this case, now let's look. If I want to find the minus of the first one, what do? I will pretend as if I cover this first column and first row. This is the leftover that I have. I have 7, 6, 4, 0. This is what I have. That will be 7 times 0 is 0. Minus 4 times 6, 24. So here will be minus 24. That will be the first minus of this first row, first column. I will go ahead to second row, first row, second column, which is 3. How do I get the minus of this 3? I will pretend as if I cover the first row and first column. I will write out the leftover. 8, 6, 1, 0. 8 times 0 is 0. Minus 1 times 6, 6. So that will be 0 minus 6. That's minus 6. This will be the minus of that second one. Then I will repeat the process for each of these entries. For the last entry along the first row, last column, first row, last column, I will have 8 times 4, 32, minus 7, that's 25. It will be 25 here. I will repeat the process for each of the entry. I'll come to second row here. Second row, first column. If I pick second row and first column, the last one will be 3, 5, 4, 0. Then what do I get here? 3 times 0, 0. Minus 4 times 5, 20. That's minus 20. Here will be minus 20. This is the process that we use to find the minus of A. If I come to 7, 7 is second row, second column. What I will have left there will be 2, 5, 1, 0. 2 times 0 is 0. Minus 5, minus 5. So this, I will repeat the process for each of these. If I want to find the minus of this 6, it will just be, I pretend as if I cover this and this. I'm going to have 2 times 4, 8. 8 minus 1 times 3, 5. 8 minus 3. 8 minus 3 is 5. So here will be 5. I'll come to last rule. Pretend as if I cover these two. I will have 6 times 3, 18. 18 minus 7 times 5, 35. 18 minus 35, that's minus 17. I will cover first column. Last row, first column. That will be 2 times 6, 12. 12 minus 8 times 5, 40. That will be minus 28. Then I will go to the last one. Where I have the third row, third column. I will have 2 times 7, 14. Minus 8 times 3, 24. This minus this will give me minus 14. Here will be minus 14. Okay. So I've gotten the minus of all the entries in A. So the minus is what I have on the board. So once I find the minus, I'll go ahead and find the cofactor. How do I get the cofactor? Cofactor simply means minus plus appropriate sign. That is, the cofactors of A will be equal to, I will do it somewhere here. Cofactor simply means minus plus appropriate sign. Look at the appropriate sign. Along the first row, I will have plus, minus, plus. Okay? That's the first thing to do. Along the second row, it starts with minus, minus, plus, minus. Then we also have plus, minus, plus. These are the appropriate sign that we have for 3 by 3. For 2 by 2, it will just be plus, minus, minus, plus. So this is the appropriate sign. If I want to find the cofactor simply means minus multiplied by the appropriate sign. That is cofactor. Then here, this is plus. Plus times minus is minus. So I will still have minus 24 here. Here is minus. Minus times minus is plus. So this will change to 6. Here is plus 25, no problem. Here is minus. Minus times minus is plus. So this will change to 20. Here is minus plus. That's minus 5. Then here I have plus. But here is minus. Minus times plus is minus. So I'm going to have minus 5 here. Then this one is minus. Minus times plus is minus. I have minus 17. Minus times minus is plus. So this one will change to 28. Then minus times plus is minus. This is minus 14. So what we have on the board is the cofactor, which is this is the first thing that we find when we want to find the adjoint of A. The second thing is the cofactor. So what is let's remember that the determinant is 95. So what is the next step? The next step is now to find the adjoint. And what is the adjoint? The adjoint of A that we abbreviate as ADJ. The adjoint of A simply means when you transpose the cofactor. That is, adjoint is when we transpose the cofactor. Transpose of a matrix simply means we change row to column. That's the meaning of transpose. That is, I will change first row to first column. I will have minus 24, 6, 25. Second row to second column, I will have 20, minus 5, minus 5. Then third row, minus 17. I have minus 17, 28, minus 14. So that is the adjoint of A. Adjoint simply means we transpose the cofactor. So we have gotten the adjoint of A. So the inverse of A by formula is adjoint of A all over determinant of A. Of course, we know the adjoint of A, which is minus 24, 20 minus 17. We have 6 minus 5, 28. Then we have 25 minus 5 minus 14. Everything divided by the determinant is 95. The determinant that we got is 95. That's the first thing that we found is 95. So this is the inverse of the matrix. The inverse of the matrix is given as this. Or if you like, you can rewrite it. If you like, you can write the inverse as, you can say the inverse of A is equal to, just bring out 1 over 95 all over this or this is still the same thing. So that's how to find the inverse of a matrix. Thank you.